Hi everybody, my name is Candice Edwards and I'm Chairman of Health Choice Massachusetts. I just want to thank everybody for coming today. I'm sure as many of you know that we are tirelessly working around the clock opposing some bills that have come into our state. And I'm sure many of you know that this is happening all across the United States right now. We have the honour of connecting with Dr. Shiva here, who has just been incredible in educating us, coming to meetings, talking to public health and really educating them on the key issues of our state right now when it comes to vaccination. Now, Dr. Shiva, I would love to talk about his entire list of credentials, which is literally as long as my height, but I'm going to hand it over to you.
Great.
And thank you so much for coming today.
Good, thanks for having us. So anyway, thank you very much. Is everyone from Northampton? People in the neighboring areas? Okay. This is, I think, the third one of a lecture like this we've done, and it's been very valuable because we've been getting feedback and how to refine it, so each time it's a little bit different. But the first one we did was at our center in Cambridge, and then we did one at North End Yoga in the North End, and then we're doing it here. So we're very happy to be here. So as Candice said, my involvement in this is really to give a scientific framework, which I believe has not existed. And it's become, this pro-vax, anti-vax community. And what's been lost in this is a sense of actually what I call truth, freedom, and health. Really starting to uncover what the real truth is. And sometimes the truth is very difficult. It's not something you get overnight. What are the issues, governing the issues of freedom, which are coming up? And then how do we get to real health out of this? So those are the three sort of the large abstract points. But what I want to do today is to lay a framework for each one of you, hopefully as takeaways, that you can start using in a way to start having conversations with people, to go beyond this vax, anti-vax model. And I think what's happened in this country for the last how many ever years, it's not just in the last 3 years, but for a long time, any issue gets busted into pro or anti, right? Or anti, as Candice would say with her accent. But it's either pro or anti. On any issue, pro-climate, anti-climate, right? Pro-vax, anti-vax, pro-Trump, against Trump, right? And that phenomenon, I don't think helps us as citizens. In fact, it allows those with power and control and desire for profit to divide people. And I think we have to reset by using a very different approach, which has existed in science for a long time. I mean, we're in a yoga studio. Yoga is really about unity. And in traditional systems of medicine, or in modern what's called systems biology, the goal is actually to look at the whole, not the parts. So looking at the parts is what you call reductionism. Looking at the whole is systems thinking. And for those who want to manipulate a situation, it's very valuable for them to take everything as a part of something. I have a book coming out. I enjoy writing, but it takes a lot of time, called The Climate of Science. It's not done. It's going to take a couple more weeks. But it really looks at the climate of science. There's a big discourse on climate these days, but one of the discourses that's not happening is who is determining what truth is anymore? It's a good, interesting question, right? I grew up in India where there was a caste system. I don't know if you're familiar with it. We were considered untouchables in India. So one of my earliest memories was this was when I was 3 or 4 years old, after playing soccer to go to a friend of mine's home, and his mother made me stand outside, and I wasn't given water. In fact, given water in a different bowl. And that's when my mom said, I asked my mom, I didn't understand this. It felt very hurtful to a kid. It still does when I recollect this. And my mom said, we're considered Shudras. She said when she was a young child going to the well, she was chased away. So in that system of that model of the caste system, there were, I don't know if you know, different layering of people. But by the way, that layering was never meant to be one of power. There was a guild system, which was based on your skill. And it wasn't supposed to be hierarchical. It was more based on, the master-apprentice model. And that essentially got manipulated to become this caste model. So at the top of it were the scribes, or what we call, quote-unquote, the Brahmins. And they essentially said that they had a connection to God or spirit. So because of that, they would organize knowledge, and that knowledge was then used to direct the kings. And the kings would use that knowledge to direct their armies on behalf of the business folks, which was the next caste and then way below was the Shudras, okay? But that's an interesting model, right? So I grew up in that environment. So as a kid, I was very politicized, but I also grew up in India where my grandmother was a traditional healer. Most villages in India did not have MDs. The women were typically the healers in those villages. And my grandmother worked and by the way, it was not a profession you got paid for. This was something you did as a noble service. So my grandmother was a traditional healer in that village, but she worked 16 hours a day as a poor subsistence farmer. But she had learned the traditional methods of a systems way of looking at the body. Now in the West, most Western MDs would probably poo-poo that because they don't understand it. It had a whole language. Some of you may have heard of it called Ayurveda or Siddha. Terms like Vata, Pitta, Kapha, Prakriti, Karma, etc. And this terminology, and there's many other terms, was essentially a part of a very different system of medicine where the body was treated as a whole. And so my grandmother could observe your face, and there's many different ways of diagnosis, and based on that, she could predict your particular state, and then figure out your perturbations or your disturbances, and then she would come up with particular formulations for you, be it massage, be it herbs, or different types of manipulations, right? So it was the important part of that medical system, it was one size did not fit all. So everyone in this room has a unique condition, a state, that's you, and then each one of us may deviate from that state, and based on that deviation, you were trying to always bring someone back to you. So in some ways, be happy, be you. So I was fascinated how my grandmother, with no degrees, tattoos all over her arms, was able to heal people. So that led my journey also into understanding medicine. So it was an interest in understanding why there were hierarchies in the world and injustice, and also how this woman could heal people. And I saw her empirically heal people with my own eyes. So I came to the United States in 1970 as a 7-year-old kid. My parents were quite unique. The fact that my mom got educated and my dad got educated in that system is quite extraordinary. So when I came to the US, I was deeply interested in medicine and understanding how the world worked. And I saw in the United States a huge opportunity because there was far more freedom here. I ended up going to MIT. I did 4 degrees in and out of there, started various companies. But when I was a 14-year-old kid, I actually started doing medical research. I had the opportunity to go to NYU as a kid, and I started working full-time at a medical school, what is now known as Rutgers Medical School, looking at why babies were dying in their sleep. I know many of you probably heard of SIDS, sudden infant death syndrome. So Rutgers at that time had some of the best data, and we were applying computing to watch sleep patterns to see if we can predict the onset of what's called an apnea. But while I was at that university, I also learned how to build other systems. Some of you over the age of 40 may know the inter-office mail system, how secretaries work. Women essentially use this typewriter system, inbox, outbox folders. They'd write a memo and they'd communicate. And this was the way communication took place in most organizations. As a 14-year-old, I was asked to convert that system to the electronic form. And that's what I did, wrote 50,000 lines of code, called it email, a term never used before in the English language. This was before I came to MIT, and this was all done in Newark, New Jersey. And when I came to MIT, the president of MIT said, Shiva, you should copyright it because the Supreme Court was not recognizing software patents. That's what I did, and on August 30th, 1982, a young American kid was given the first US copyright for email, recognizing him as the inventor of email. The reason I shared that story was that was not done at MIT, wasn't done at Silicon Valley, wasn't done by the military-industrial complex. It was done in a health sciences institution to help women move from the keyboard to the typewriter. From the typewriter to the keyboard. Now, several years later, about 6 years later, all of this stuff went into the Smithsonian, and it created quite an extraordinary controversy, because the narrative was that email had come out of the military-industrial complex, which it didn't. They did simple text messaging. And you can read about it, it's all over the web. The reason I bring this story up was, when I was at MIT, those many years doing all those degrees, I was on the front page for inventing many things. But when I said email was done before I came to MIT, it created an interesting dialogue, more than a dialogue. Because the narrative is that all great innovations must come from war, which is killing people. That it surely could not come from a health sciences institution. But that's the origin of email. But the deeper story is, where does innovation come from? Where does creativity come from? Where does life come from? Does it come from us going around, doing war? Or does it come from actually practicing the art of healing people? So the origin of email comes from that, but more importantly, when you look at where we are today, most of science today, which I want to go through, has moved to a model, particularly starting in 1970, to what I call pay-to-play science. And most of these major institutions now, you have to really start thinking about the difference between an academic and a scientist. In 1970, there was an amendment called the Mansfield Amendment. And the Mansfield Amendment basically moved tremendous amount of money, which was dedicated for basic research, to the National Science Foundation. So up until then, scientists could do a lot of basic research, which means they could be funded to do some very wild, innovative research without the pressure of a lot of money. But after 1970, the Mansfield Amendment, it basically said no money in basic research from the military could go unless it was for weaponry. So starting in 1970, you start seeing the changing of scientists to become academics. So, and academia has now become, some people say, the oldest profession in the world. And why did that happen? Because academics, yep?
I don't know if we could ask questions. I'm curious, were these people working at universities or business when you were referring to them like as scientists?
These were working scientists. So these were working scientists, yeah. So think about the way academia works is you finish your PhD and then you want to get, you get on what's called, does everyone know how the tenure process works? So this is how it works. So typically the goal in academia is to get a job for life. So you have 7 years to do that. So let's say you finish your PhD and you start working at XYZ University. Well, they give you 7 years to publish work that proves your eminence in a field. And if you prove your eminence, put that in double quotes, then you're afforded the opportunity to become a tenured professor. But you have 7 years. Literally, it's a 7-year horizon. So how do you get tenure? Well, you have to publish papers. So first of all, you have to take a very focused field, and you have to try to become one of the experts in that field. So you publish a lot of papers, but that's not how you get tenure. So let's say, what's your name?
Jim.
So Jim, let's say you're in the field of cancer biology or immunology or vaccines, and you want to try to get a tenureship in that field. Let's say everyone on this room, or Candace, is like the expert. Like she's the one that she sits on the nature review boards, everyone bows down to her because she's been in the field for 30 years and she's at a different university. So when you're going through your process, you're publishing. After those 7 years, a review committee will decide, is Jim going to get tenure? So what they look at is not only the publications you did, but how many other people, your peers, cited your work. So if Candace was writing a paper, did she refer to Jim's paper? And if she did, then you are deemed as, wow, you're pretty extraordinary. Candace even referred to your paper. You follow? So the gamesmanship here is you want to please Candace. So how do you please her, right? You may come up with something quite innovative in the area of vaccines or immunology. But if your discoveries or your path goes against the head of that field, it's probably going to be very difficult for you to get tenure. Everyone follow what I'm saying? So the peer review process, what they call peer review as some gold standard, was set up essentially to bring people into line. So universities were supposed to be a place where people went to do radical research, to have free speech, etc. But after 1970, because so much of the funding got cut or honed into one organization called the National Science Foundation, which is a very political organization. Prior to that, you didn't have that much politics. You as a scientist are chasing money, because you need money to fund your graduate students and yourself to write papers, and you're also chasing you're bowing down to others in your field, otherwise you're never going to get tenure. Everyone understand this environment? It's the peer review process. Now Einstein, just to let you know, never published one paper peer reviewed. Because when he submitted one of his last papers, he submitted it, and the editor said, oh, we're going to send it out to peer review. And he goes, what are you talking about? He goes, how can peer review ever support innovation? Because a peer review process is fundamentally made up of, the peer review process is fundamentally made of getting your peers to agree to you. But if you're doing something innovative, your peers are never going to support that. Does that make sense? So that is the scientific model. So you have to understand what's going on here to understand this environment. Does that give you an understanding of essentially the academic environment? I wanted to read you guys something that it's in the first chapter of the book, but I thought my goal here is to really educate you on some of these very, very deep concepts which never come out in any of this discourse. Do you mind if I just read you this few pages? Okay. It's called Freedom or Slavery. This book is about you specifically about you reclaiming your humanity and reconnecting with the noblest of human aspirations, truth, freedom, and health. However, for those who crave power, profit, and control, their gain comes at the expense of our disconnection and division. They distract us with problems that aren't real and which quote-unquote solutions that solve little except to divide us into quote-unquote left and right while discouraging discourse, debate, and discussion. Such an effort is not accidental, but deliberate, using a method in science known as reductionism. Reductionism can best be understood from the parable of the 6 blind men. Everyone know this parable? It's a famous, Buddha brought in these, he tells the story of this king, the 6 blind men, who were asked by a king to feel an elephant and to share what they quote-unquote see. One reaches out and touches a tail to be convinced that he's come upon a braided rope. The other feels a tusk and is sure that the object is a sharpened spear. And the one who stumbles into the legs is convinced that the elephant is an oak tree, and so on. None of them see the elephant, the whole, but are divided by their glimpses of a blinded reality. We too are blinded and divided into our collective misunderstanding of the major issues of our time, be it climate change, vaccines, immigration, healthcare, foreign policy, education, gun violence, agriculture, or the economy. These are big elephants. Complex systems, large-scale, interconnected systems of many parts, systems of systems. Such systems cannot and should not be reduced to a single component, like an antibody or CO2, right? Or to a single variable as a shortcut to understanding the whole. Yet this is what happens. Everyday politicians, celebrities, and academics sell us their faulty conclusions from reductionist thinking, a fake problem alongside a fake solution. They dramatize a problem and weaponize it into sound bites, compelling us into fear, uncertainty, and doubt, so we react and buy their quote-unquote solution. Reductionism serves to shackle freedom so as to disarm the scientific method, which is a foundation of science necessary to uncover truth, the whole, from which we may discover real problems and innovate real solutions for the health and well-being of our planet, our body, and the world. I say by the time you read the last page of this book, you'll learn how this process works in practice and in theory. You'll learn that reductionism perpetuates itself by creating a mob of quote-unquote educated and vulnerable elites who are trained to rationalize anything, emboldened and entitled to give their expert opinion on any topic and regurgitate false narratives without any grounding in science and, more importantly, engineering principles. None of this is new. It has been going on for a long, long time. The only difference is now a far few number of people and a handful of megacorporations networked across East and West without borders or walls deploy reductionism to corral that mob and manipulate billions with unimaginable speed, precision, and efficiency. Furthermore, we're at a turning point in history, transitioning from the industrial era to the information era, where new technologies deployed without our consent, I think it's a big part of this, right, can deliver us to a darker age where our humanity is decimated to reducing us to machines, automatons, artificially intelligent, wage slaves in greater debt and servitude as never before. But here's the good news. Ordinary working people are not buying it into this nonsense like the mob of vulnerable educated elites. The good news is that we have a choice to move beyond reductionist thinking and centralization of power, which thrives on crisis, war, and conflict, to a systems thinking that empowers science to identify and solve real problems, to decentralize power to the edges, to deliver us truth, freedom, and health, and to bring us to a golden age where our humanity and our divinity unfold, so each of us uniquely may pursue life, liberty, and the pursuit of happiness. In 1960, President Kennedy asked, quote, whether the world will exist half slaves or half free, whether it will be move into the direction of freedom or whether it will move into the direction of slavery. Today, that question remains more relevant than ever before, freedom or slavery. This is our choice, this is your choice, and health choice is a great name. So I want to give that context. Does that help?
Yes.
And thank you. So that chapter probably took about 20 years to write, okay? But the issue that I wanted, so I think you've given it, hopefully I've given the sort of how the scientific system works, but this is really the core of it. You know, humanity has always, we've always sort of taken little breaks into this wall of, power, profit, and control, right? It's always been one step forward. So we were slaves at one point, right, in shackles, and we sort of fought for that, and we got into serfdom, right? We were given a little piece of land, and we had to pay homage to a king, and then you could argue that we're now wage slaves, but it's always been a step forward in some sense. And I think, in my view, the vaccine controversy is a huge opportunity. It's a tremendous opportunity to wake up and to realize that this opportunity on vaccines brings up all of these three issues: truth, freedom and health, and the antithesis, which is profit, power, and control. It's an extraordinary opportunity, because what's happened is that on the area of truth, are we applying the scientific method, or are we using scientific consensus, right? On the freedom issue, the entire purpose, if you take one philosophy of existence, is we are supposed to pursue our dreams, in our pursuit of happiness. That's what the United States was based on. Many spiritual teachings were based on that. You have a dream, I have a dream, and we each have our own path. And the goal of life was to eliminate those barriers. So the issue of freedom is central to this discourse. And finally, health. Health is finally one of those things, be it the health of your body, the health of your community, the health of your business. These decisions are very complex systems. So in this discourse, I've used the word systems a lot. So I want to give you a framework of how do you actually understand systems. So one of the great developments in humanity was the field of engineering. What's great about engineering is scientists can sort of BS themselves. Scientists essentially, I don't know if you know how science works, you do experiments, and you basically sometimes draw a line. You may have some axis here, right? And you get points, right? You draw you say this is your data, right? And then what you do is, for this set of data, you fit a line to a curve, right? So you may say, someone may fit the line like this, others may fit it like that. And then these lines will result in some law, like let's say F equals ma, or someone may say F equals ma squared, okay? So you're basically collecting observations, you're fitting a line, that's called a model, and you come up with an equation, which is a equation which hopefully is evidence, because evidence is repeatable predictions. That's what the definition of evidence is. So if you come up with something like this, turns out F equals ma is what Newton discovered, right? The reason it's called a law is because over and over and over again, we've seen these observations that, force is directly proportional to acceleration with mass as the variable, right? So, or however we want to look at it, but this is a law which came from the scientific method. You saw an observation, you had a hypothesis, you collected a bunch of data, and then you developed a model and you iterated. This is a science, right? So you iterate. Yep.
When you're bringing Heisenberg.
Right. So what happened with F equals ma was, even this, Einstein discovered that when things move at the speed of light, that you have to correct for F equals ma. This is true for certain objects. The point is, even Newton's first law had to be later corrected. But that's the great thing about the scientific method. You're always entering into uncertainty. You never have arrogance. Okay? You don't go into arrogance. So let's consider. So I think the takeaway from here is, in the scientific method, you come up with what you think the world is like, but then you do experiments, you get a lot of data, and this data you plot on some type of curve, and then you try to figure out how this data manages itself. And evidence, or a good model, is something that's reproducible. All right? The problem with science is this: scientists can BS you and me, because they're fitting a line to a curve. The real, where the rubber meets the road, is engineering. There's a difference between science and engineering. I can build an airplane and I can say, this airplane works, I'm applying Bernoulli's principles, but if that airplane doesn't take off the ground, it doesn't matter what you think or what the science is. So engineers, plumbers, electricians, those of us who are a yogi, right? We have to work with nature's laws. You can't BS your way out of that. You follow what I'm saying? There's a fundamental difference between engineering and science. The scientists, many ways, if you want to use the analogy, are the priesthood who comes up with ideas, because they tell you, this is what I believe, I have some deep connection. The engineer is a worker out there who's actually experiencing reality. And in engineering, the other difference is you are always pressured to listening to your customers. So let me give you an example. Civil engineering, what do? We build what? Bridges, roads, right? You go through a process. If you're building a bridge, there could be hundreds of different suppliers of that building material. You have to go through a whole process, permitting, etc. Right? You go through this whole process, you get a bridge. In naval engineering, what do? We build ships, right? We take very complex parts and pieces, we bring human labor together, and we build this thing called a ship. In space sciences, right, we build aircraft. In 2003, a new field developed in science called biological engineering. It's not biomedical engineering, it's not chemical engineering, it's called biological engineering. Why did biological engineering develop in 2003? A couple of reasons. In 2003, something important happened. The Genome Project ended. I don't know if you remember this, they finished the Human Genome Project. We went into the Genome Project thinking what made a human being different than a worm was genes. So biologists who are not engineers, or medical professionals who are not engineers, thought that the number of parts equated to complexity. So then we knew a worm had around 20,000 genes in 1993, and we thought, wow, look at human beings, we're so much more complex. We must at least have about 500,000 genes. Well, when the Genome Project ended in 2003, it turns out we only have 20,000 genes. Okay? Now, an engineer would never, a systems engineering guy would never do that, because it's not the number of parts, but it's how you connect the parts. If I give you 10 balls, you can connect it in a line, or you can connect it in very different ways, right? The complexity is a number of how the things are connected. That's systems thinking. Is that, I know I'm hitting you with a lot of information. Everyone following? So in engineering, engineers are putting together parts or building very complex systems. So when the field of chemistry developed, people realized, wow, we understand how chemicals work together. Then a field called chemical engineering came, which was let's use the laws of chemistry to build things, right? TNT, bombs, or whatever, right? Or ice creams, right? All these industries came from chemical engineering, perfumes, etc. But in biology was starting to figure out how biological systems were working, right? How transcription worked, translation worked. So in 2003, when people realized we have the same number of genes as a worm, biology was flipped on its head, and we realized, wait a minute, genes aren't the cause of everything. It's not a linear model. It's highly nonlinear. We have all these chemical reactions taking place. In fact, maybe what we think and what we eat can turn off and turn on genes. It was a field called epigenetics. And so starting in 2003, people realized that we need to move away from this command and control model, the centralized command and control model, right? The nucleus is the center of command and control, and everything is dictated, but it's not actually true. Our bodies interact with the environment, we interact with pathogens, we interact with all different kinds of things. And what emerges from us, we're not just us, but we're an emergence of what occurs from our interactions. Food, thoughts, and your genes. So that led to a field called systems biology. And systems biology said that we need to start understanding the interconnections of these molecular reactions. So in 2003 is when I came back to MIT, because I'd been in and out of MIT, did, as I mentioned, 3 other degrees, but I always wanted to do medicine, and was very upset every time I used to step into the medical model that it was never looking at the body as a whole. I had this instinctive reaction against traditional medicine. So, but systems biology seemed cool because the idea was you could bring together engineering and understanding the body as a whole. So I came back to MIT in 2003, and I spent about half a decade building a whole new technology to model molecular reactions on the computer. So today, when we build an airplane, we don't just throw a pilot in, it's all modeled on the airplane, we understand the laws of physics, right? But when we build medicines today, pharmaceutical companies can only handle a single molecule. They do stuff in a test tube, and then if they think that works, let's say they drop some chemical to kill cancer cells, then they go test it, kill a bunch of animals. That takes around 6 years. Then they get allowance by the FDA, and then they get to test it on humans, phase 1, phase 2, phase 3. It's about a 15, 16-year process, $1 to $5 billion, and the medicine that comes out of there has many side effects. In that old medieval model of drug development, which we still use today, you are treated as a statistic. You're not treated as an individual. Oh, they draw some graph and they say this medicine works for this statistical group of people. And based on that statistical group of people, they use 2 measures, efficacy and toxicity. Okay, efficacy is does this actually work? Toxicity is the dosage. If I give too much of this, will it kill somebody? The FDA is supposed to be really focused on the toxicity issue. The efficacy is something that I, as an innovator, have to prove that it actually is efficacious. You got it? So 2 metrics, efficacy and toxicity. So the drug development model, however, was designed only for a single synthetic molecule, and a molecule that does not occur in nature, because that's how you get a patent for it, okay? Herbs, yoga, these things are not synthetic molecules, they're combination therapies. So the conventional system of pharmaceutical development has no way of really validating any of these things because it's made based on a single molecule. So in 2003, so I built this technology, and by the way, you can read more about it. It's a company called Cytosolve. We actually are figuring out how combinations of nutraceuticals work. We're goals to eliminate some of the snake oil and the supplements industry. So in many ways, I had the opportunity to do what my grandmother was doing, right? And we have the ability to do personalization. But the point I'm making is starting in 2003, even medicine in the United States, and for that matter the world, even conventional medicine realized that this old model of development had serious problems. It didn't work. That's why all those commercials, if you watch prime time, it's always some drug and then they give all the side effects, right? Because they know it doesn't work for the individual, so they cover themselves by that very idiotic model in many ways, right? It really is not helping anyone. So medicine moved into a field called precision and personalized medicine. I want to write that down. Precision medicine or personalized medicine. And so what precision medicine and personalized medicine said is one size does not fit all. And by the way, Massachusetts, the area around Kendall Square, is supposed to be the center of this. So we are supposed to be in the center of the entire biotech industry of the world, where the trajectory, even Francis Collins, who's the director of the NIH, it's about precision medicine. It's not about giving everyone a set of protocols. It's about you are different than you and you're different than you. And the concept of giving one size fits all is a medieval model. Now, go to 2,000 years ago, 5,000 years ago, traditional systems of medicine didn't follow that. My grandmother gave you a very different set of yoga exercises, even though you may have the same issue than somebody else. So the notion of personalized precision medicine, we're sort of going back to the future, we're rediscovering that. So that's the other pillar you want to think about. We have the fact that the scientific method is where we really figure out truth, but when it comes to health, there's a recognition that we have to follow precision, personalized medicine. One size does not fit all. Does that make sense? So in 2003, when this discovery came, the irony of the Genome Project, realized genes are not everything we are, a field got created called biological engineering. Okay? Not biomedical, which was about devices, a whole new field. And biological engineering said we can now use our understanding of biology, like people are starting to understand how different pieces work, to actually engineer things. So one of the important points here to understand, vaccines are a product of biological engineering. Just like a bridge is a product of civil engineering. Just like an aircraft is a product of aeronautical engineering. Okay? And this is probably one of the central points I think that'll help in this discourse. The people who are claiming expertise in this field, pediatricians and MDs, actually have zero expertise in this field. Now, why do I say that? If you go to a pilot and you're getting on the pilot and you ask the guy, can you tell me the risk assessment of this Boeing 747? He's a pilot. He's not going to give you he has no idea of the entire supply chain that it took to create that 747, all the processes it took, all what are called the risk analysis model. We're hosting a science conference, and everyone's invited to come on October 26th, and it's a risk assessment. It's an international conference on vaccine risk assessment. When I started looking at this field, there is no risk assessment done. For two reasons. One, which many of you already know, that about the 30-odd vaccines that are for kids from 0 to 18, none of them had saline double-blind placebo-controlled studies. How many people knew that? Okay, everyone know what that means? Double-blind placebo-controlled study? If you don't, I'll give you a quick. You know. So basically, in the scientific method, what you're supposed to do, the gold standard is, let's say a group of people here, I'm going to test a new vaccine. I take one group of people, I'm going to give them the vaccine. The other group of people are not going to get the vaccine. They're going to get essentially saline water. Okay, that's why it's called a saline placebo. Now, what does double blind mean? Well, all of you people are mixed together. I give half of you the vaccine, but none of you know what you got, because that could affect the experiment, and the other half are getting the placebo. That's called a single blind, which means none of you know what you got. The double blind is I, as a researcher, also don't know. All I get is numbers, big table, like whatever. In this case, they're looking for the efficacy. In the vaccine model, they look at, I gave the vaccine, was an antibody upregulated? All right, and we'll talk about that. And so of the 30 vaccines, about 70 doses that are prescribed for young children from 0 to 18, none of them, and I'm going to use none of them, have had double-blind saline placebo control studies. The one that they claim, Gardasil, which supposedly had one, was in many ways an unfortunate, I would say, fraud, if you actually look at it. The way they did the placebo was half of the people got the vaccine. The other people, in a saline, there's not supposed to be anything but saline. Vaccines use a transport mechanism in the modern world to make the transport of that vaccine particle more efficient. They use different adjuvants. In this case, they use aluminum sulfate. So the aluminum sulfate is almost like the Uber driver who's taking the passenger, who is some type of either live or dead, typically a dead particle, double-stranded RNA or something like that. And the aluminum is essentially driving this thing to make it more efficient. Well, one group got the vaccine. The other group got just the aluminum. Okay, so I believe 10,000 got the vaccine, about 9,600, 9,700 got the aluminum, and 360 people, or somewhere near there, got saline. It's very interesting. I don't understand why they choose. There's some theories on this. So they actually did 3 groups. One group got the vaccine, another group got the placebo, but it's not saline, with just aluminum, and the third group got the saline. Okay? Then they looked at the results. It turned out the vaccine people got their antibodies. However, for toxicity, supposedly risk, 2.3% of the vaccine group got some type of autoimmune issue. Okay? 2.3% of the aluminum people also got, very interesting, exactly 2.3%, also had the aluminum issue. And of the saline group, 0% had any issues. But in the Gardasil package insert, they combined these 2 groups. Okay? And they said it was a saline placebo-controlled study. So I don't even consider that a real study. So the point is, that's one, so this concept of double-blind saline placebo-controlled studies is used as a gold standard in science. That hasn't really been done, I would argue, among those 30 different vaccines. But there's a bigger issue that I want to arm you with, or to arm you with in the sense to think about. If you look at a vaccine, no different than a bridge, or a car, or a plane, in the field of engineering, if you were to look at the development of any of those other objects, we're going to be talking about this at our conference, but there's a whole process that the development trajectory goes through. So there's different levels of process. So, supplies, where's the suppliers coming from, right? The manufacturing process. I'm just giving you some of the ideas here, right? The actual construction, and then the delivery, okay? There's all these steps, and along these steps you can draw all these very cool diagrams. You calculate at the end of it risk. And this risk is calculated by all these probabilities of failure. It's a very complex engineering systems risk assessment process. It's a field, engineering risk assessment, okay? So, I have not found anywhere, and here is a vaccine, right, the end of it, or a bridge, right, or airplane. So, I want to propose that we need to look at this because it is a product of biological engineering. Now, way at the end of this process, the deliverer of this is either a pilot, right, or an MD, or somebody else. I would argue that these people are like tech support people. All right? At the end of that process, they know nothing about any of this. And I would claim that the amount of participation of them in this conversation is frankly inappropriate because they don't know about this entire engineering process. You follow what I'm saying? They're literally like tech support. It would be like asking a pilot what does he know about the possibility this plane could crash. They're actually unskilled. So the people writing books on this topic, on this level, actually have no expertise in this. So it gets even more interesting. If your Apple iPhone breaks, right? Or and I've run many engineering companies, whenever I put out a product, if one customer out of all of you calls thousands of customers and says, hey, I'm using your software on the Chrome browser and it's not working, suppose I said, you don't know what you're talking about, it's working for everyone else, bye. Imagine someone did that to you. Hey, it works fine, my software is great. Or, out of the hundreds of thousands of 747s and Boeings, 3 fall out of the sky, right? And you say, well, that's no big deal. That would be unacceptable behavior, wouldn't it? Right? In engineering, first of all, that company would go out of business. It would be unacceptable because in engineering, you are held up to much higher standards. If you have a plumber or an electrician, he wires your house and he doesn't ground it, and things start. You as a customer, no one would say, well, that was just one incident, it's an anomaly. And I would argue the reason the reaction is taking place when mothers are bringing up their customer service issues, that's what this really is, and the reaction by these people, the MDs and the pediatricians, is quite profound how they react, which an engineer would never react to by and large, or it would get caught pretty quickly, you'd be fired, okay? Happened with the space shuttle, right? Many other things. A mistake occurs, eventually it gets caught. Is a difference in engineering and what's taking place in biology is when I build a computer and I build a piece of software, I am putting that together. You see? I know all the parts and the interconnections. So there's a level of accountability that I have and a level of humility. Because I know I put it together, I'm accountable for it, and the ankle bone is connected to the foot bone, and if something's not working, even one person's complaint, there's a great book written called A Complaint as a Gift, is an opportunity to figure out something with my process, for process improvement. Now, the interesting thing with the body is, it's an engineering system also. The difference is we don't know all the parts. We don't know how it's interconnected, right? Nature as the engineer, if you have a spiritual perspective, built this thing. But it does have certain levels of predictability. We can understand it. There is mechanistic understanding. But the MD or the pediatrician has no idea of this interconnection. They are brought up as though they are gods. But they don't even have the humility of God, in some sense. God actually gives all of us, in some teachings, freedom to make their own decisions. So this arrogance comes from, in my view, a lot of insecurity and fear, because unlike the engineering model where you actually understand and you have a humility that you can fix things, here, the body is a very complex system. We don't understand how these components are interconnected. The MD and in their training has been deified to be godlike. Like they do have all the answers. And so I want to propose that there's a mistake that has taken place in the development of this profession, where this humility has been lost. Because, again, in engineering, you cannot afford to do that because you'll be out of business very quickly. Yeah?
I was going to say, but I don't know if people are aware, this was a movie that was made in this very city about that topic with Richard Gere called Malice, where basically he did have that exact same job complex.
Yeah. I just want to start this, make sure this is going, because people are... but I want... Yeah, so you're right. So what I'm saying is there is this other phenomenon that takes place that doesn't take place in the other physical areas of labor, etc., where you're creating products. This is a sort of an epiphany I've had over the last about a month as I started thinking about this, because I want to be objective on this. Why is there the reaction of these people to this extent? Yep.
I also feel like if you were to see that you could be hurting someone in your life's profession is built upon helping people and caring about people, and to think that you did something that had been in this process, that would be hard to even question as well.
Yeah, definitely.
Your own personal beliefs,
Yeah.
based on your own life experience, based on your own livelihood, based on everything you've ever known. That's why you have your doctors.
Yeah, I think you're right. How are we doing on time? Are we okay? Everyone getting bored, or should I go? Okay. So I think what I wanted to make sure is a couple of the things that we want to cover is we've talked about this entire aspect of this engineering process, but here's where the vaccine thing really we can start looking at. So the precision personalized medicine, everyone understands? We understand how engineering systems are worked. There's a whole process that vaccines are a product of biological engineering. They're just not a medicine a doctor's making in their room. There's a whole bunch of people involved in this process. One vaccine may have many different chemicals involved. There's a processing methodology. There's a whole bunch of systems that it goes through. Yeah, Jim.
If you're planning on going in this direction, you can kind of dismiss the question. But I'm curious, in that scenario that you were describing, you're saying that the MDs don't have the knowledge to make these decisions, but we're holding them accountable and responsible, and they feel compelled to act like they have the information. And you're saying that the engineers and these companies that are developing the products should be, or could be, more accountable. What is the way of figuring out who's accountable? Because I imagine in some cultures and communities it's the individual or the doctor or the government or the company. How do you navigate who to hold accountable and have some sort of consistency so that there can be the right checks on?
So the issue is, if you have a democratic society, this is a decision that's made collectively. Now, in the vaccine case, in 1986, the unfortunate events that took place was we removed that accountability, because for vaccine injury, the courts essentially protected the developers of vaccines, and they said that the government, Health and Human Services, would become the umbrella, which is the government, right, which is our taxpayer dollars, to manage liability of vaccine injury. Okay, so decoupled the creators of this from the products that they were creating. This would mean like Microsoft could produce products, and if you had problems with them, you have to go sue them in government courts, and Microsoft doesn't have to pay anything. Or if an airplane fell out of the sky, right, you can't go sue Boeing, that the government intervenes. But it was even more unfortunate because they limited the amount of liability to around, I think, $250,000. So that decoupling took place, which is anti-democratic. But the larger issue here is, in any of these engineering products that are created, we as a society have this notion of, hey, I want to do things with my life, my individual liberty, but there's also the collective, how we work together. So take, for example, cars. Cars are an engineering product. We know that we all drive our own cars, and at some point there's going to be an accident. Okay? So how do we collectively decide that? Well, some people decide not to drive cars, right? Other people do, and if you do, you get something called insurance. That insurance level is also personalized, okay? Which means that an 18-year-old kid who has 20 DUIs has a very different insurance rate, or probably is never driving, versus a 60, 70-year-old person who's never had an issue, right? So we have collectively agreed that we will, if I'm going to drive a car, we agree to get insurance, but those insurance rates are modulated. They're personalized in some sense. So this is a concept of risk. So this entire aspect of risk, there are people called actuaries who do this. When I started trying to understand risk here, going back to this engineering systems model, like, I'm going to take a vaccine, or I'm not going to take it, I as an individual. Can you tell me the risk? Actuaries can tell you .00, significant figures, percentage points. You as an individual, if an 18-year-old, you're drunk driving, I can give you your trajectory. Because people have done this enough. So the risk assessment models are what are key. So we've talked about personalized precision medicine, we've talked about engineering systems. So now I want you to start having an understanding of risk. So I want to take a simple way that this probability works. Let's say there's all these bridges in Massachusetts, and we collectively, or there's some understanding that whenever a hurricane occurs, that 1 out of those 100 bridges falls down. Okay, so what is the failure rate? What's the percentage? 1%, okay? So we have data showing that when hurricanes come, a bridge will fall down at a rate of 1%. You got it? So then we collectively, let's say we're in this town and we're all the representatives, we decide, you know what? That 1% is too high. We collectively said that risk is too high. So we're going to reinforce all those bridges. We're going to put some reinforcement technology. Why? Because we want to prevent, we want to reduce that 1%, maybe to like 0.01%, okay? But we collectively as a citizenry agree to do that. And we may decide to take a portion of our tax dollars and spend billions of dollars because we realize there's reinforcement was not done, and we start putting reinforcement as preventative measures across the thousands of bridges across Massachusetts. We may spend $100 billion, okay? So we put this reinforcement technology in. You know, about 5-10 years goes by, and guess what? We find out when hurricanes take place now, 2 out of 100 bridges are falling down, okay? So what's the number? It's 2% failure. What was it before? So at that point, what we see is we see a correlation, right? Oh, we put in these bridge reinforcement, now we're seeing greater amount of bridge failures. Well, we would not go to the construction guy and say, hey, what the hell are you doing, right? And he would probably not be so arrogant to say, you know, screw off, right? They would start looking at what happened, you know, was it the bridge? We as a society would demand that they did risk assessment. And they would then find out what was going on, you know, or try to figure it out. Now, that's on a collective level. Now on an individual level, let's say each one of us had a house, and we had a moat around the house. And the government said, you need to reinforce your bridges around your moat. Like you had to pay for it, okay? Knowing that there's a 1% number out there, and there's a 2% number. Research is going on, we don't know why. How would you feel? You would not probably like that. Maybe it's costing $100 grand for you to upgrade your bridge around your moat. So that is in a sense where your individual decisions are being forced upon you by data that we still haven't figured out yet. So if you use that analogy, when you start thinking about this whole notion of risk, someone has to calculate that risk. In the case of the bridge, you say 1%, 2%, you're pretty good data to say, wait a minute, I'm not going to do this, right? It doesn't make sense. I'd rather take that 1% risk. You follow what I'm saying? Who is deciding these risk numbers? Do you know who figures out? In insurance, it's actuaries. It's really smart mathematicians. John Kennedy gave a very famous speech in 1963 to the National Academy of Sciences. It's a speech that's not really talked about a lot, but he tells these 2,500 scientists, he goes, the systems of our society have become so complex now that we rely on you to help us figure out these very complex, you know, the immune system or healthcare systems or meteorological climate systems. We rely on you as scientists to help us make decisions. And a lot of that decision making comes down to risk. But in Kennedy's speech, he made something very interesting. He said, however, that's based on you being disinterested, objective third parties. Okay? That was an assumption that you're doing this for noble service of humanity, that you don't have an interest, like you're not going to be motivated, the results of your science is not moved by some particular idea. And getting back to what I started this talk about, that has fundamentally changed with the Mansfield Amendment. There is a serious problem in science right now. It's become pay-to-play science. I mean, we can have a longer discussion about climate systems and all these, but all of these systems now, it's become the blind man touching the elephant. You can take any of these systems and you can reduce it to, in the case of climate, CO2, and you can get people also very, very scared. And I'll talk more if you want the question and answer period about that. Or you can take genetically engineered foods. Monsanto can say everything is fine, when by the way, there's no risk assessment done at all on these genetically engineered foods. So, but the notion was we had disinterested third parties. And furthermore, in this environment, we in Massachusetts and the country know that medicine is moving towards personalized precision medicine. But we're forcing everyone to take these standardized set of vaccines, and it's decided by state to state. So in this model, so if you look at the vaccine model, polio is one of the great, seen as a great pillars of Western medicine, right? Jonas Salk had this great imperative to get the vaccine out. In that model, the measurement that he was using was, you know what? The antibodies. If you give this vaccine, are enough antibodies being generated? So, quick immune system lesson. There's the innate immune system and there's the adaptive. How many people know about these two? Okay. So let me explain how, at a very high level, there's a paper I'm writing on this that's going to explain this, but your body right now is getting hit with all sorts of microbes in this room, okay? How are those microbes coming into you? They're not going into your bloodstream. We're not injecting something unless you have a cut, right? They're coming into you through your innate immune system. That includes the mucous membranes in your eyes, your nose, right, your mouth, different cavities in your body, your skin, right? But it's typically coming in through these mucous membranes. And those mucous membranes have macrophages, neutrophils, these different things that are constantly, right now as we speak, deterring these viruses, these pathogens. That's called your innate, non-specific immune system. At a high level, think about it as soldiers that are in this front, in the first areas of attack, that just shoot at anything, okay? They're not specific, okay? So they have a system of tanks and these kinds of things to go attack these pathogens. The second level of that immune system is typically called the adaptive immune system. That immune system is like sharpshooters. They're really good at taking out one type of target, okay? So if you get measles, let's say, coming in through your nose, right, and it goes through your respiratory system, that's going through the innate immune system, and that immune system will get initially innervated, turned on, stimulated, and it's typically around a 72-hour time frame. That's why whenever you get a cold or a virus, you notice it's about 3-4 days, right? In the case of measles, you get what? Rash, redness, etc., itching. And then after that, 4 to 5 days later, your adaptive immune system kicks in. It's sort of layer 2, and it will produce particular soldiers called antibodies just to handle that measles virus. Got it? We could study the immune system, you could study it for your whole life, but think about it, there's a frontal layer, which is non-specific, which sends things to attack it. That's where you get the fever and all that. That's actually quite healthy, okay? Your body's trying to ward off something. And then the secondary piece called the adaptive immune system, okay? Now, I'm finishing up some work. It turns out there's a middle layer between the innate immune system, your specific, and the adaptive. There's a linkage system. My research, my PhD work was based on that, understanding those mechanisms. And these are molecular reactions. Our body has very interesting machinery. What I can tell you, a glimpse of, I haven't written this up yet, it'll come out before the 26th, is that your body, if you actually look at this, was created, engineered, to actually be in symbiosis with these pathogens. Okay? In fact, your body has machinery at the innate immune system level to trigger a set of responses which are not just the antibodies, which are later. Those chemicals that your body triggers, many of them are extremely valuable in protecting you against autoimmune disorders. This is not widely talked about. So you have your innate immune system, this linkage system I want to call it, and your adaptive, okay? And by the way, this adaptive actually feeds back. It's another whole conversation. When we get a vaccine, typically the ones that are going into your bloodstream, they're not going through the innate, they're not going through this middle system by and large, they're literally going into your bloodstream. So it turns on your single sharpshooters, which is the antibodies, okay? So in the entire system of vaccine development, starting with Jonas Salk, the efficacy of a vaccine was based on, do you get those antibodies? You got them, great, it's working. Fine, case closed. And Jonas Salk, by the way, I'm sure he was a very good human being, but he was under a lot of pressure. I don't know enough about him, so I'm going to give him the benefit of the doubt. But he was against double-blind placebo-controlled studies. I don't know if you know that. He wrote a letter imploring the Vaccine Commission not to do double-blind controlled studies because he did not want, the impetus was to stop this virus. So one of the takeaways here is the entire area of vaccine development started with efficacy as the number one goal, but again, a reductionist model of just looking at one variable, the antibodies. What about all the other stuff that could be getting upregulated, which means created, when it goes through naturally, and maybe those could be protective to you? Again, complex systems, reductionism is looking at one variable, complexity is recognizing there's many things going on. So I would argue a reductionist model has been applied to vaccines, separate from all the other stuff I've talked about here today. Does the antibody turn on or is it turned off? That's it. toxicity was never even on the table from day one. Okay? And if you want to talk about toxicity, it's seen as though you want to attack vaccines. There's a huge halo around vaccines, much more than there's even around drugs. You know, synthetic drugs, at least they have to go through some testing, we have to put side effects, but vaccines sort of got out of it because vaccines are the hallmark of Western medicine. The interesting aspect here, and how they got away with this, is the last piece I want to leave you with, is, have you heard the ethical argument? So everyone wonder why they do not do placebo-controlled double-blind placebo-controlled studies, or it's not really a requirement. This is what the wording says. You can go to a number of these writings, and this is what the literal wording says of why we don't have to do testing on vaccines, okay? By and large. It says, if, I'm quoting this from, there's a history of vaccine site, you can go to it. It says, if, and listen to this very carefully, if there is already a known vaccine that is safe and effective, it is unethical to randomize children into a vaccinated group, which means double-blind controlled studies, because we would be denying them the benefits of being vaccinated. So it's a tautology, okay? It's a chicken and egg. If there's already a known vaccine that is safe and effective, it is unethical to randomize children into an unvaccinated group because we would be denying them the benefits of being vaccinated. Now suppose you use that same argument to talk about something like an herb, okay, which has been used for 10,000 years or thousands of years, which we know has very powerful properties on hepatic function, like liver cancer, right? Turmeric, by the way. So suppose we were to tell them, if there's already a known herb that is safe and effective, it is unethical to randomize people into a group not receiving the herb because we would be denying them the benefits of the herb. That would be unacceptable, right? That's why the FDA forces you to put that star, most vitamin supplements, because you can't make that claim. Okay? Now, just to make this point even more clear, since we're in a yoga center here, if there's already a known yoga posture that is safe and effective, it is unethical to randomize people into a group not receiving the yoga posture because we would be denying them the benefits of the yoga posture, right? NIH wouldn't accept that, right? No one can claim, do this yoga posture because it'll relieve spinal stenosis, right, for example. Or if there's already a known chiropractic manipulation that is safe and effective, it is unethical to randomize people into a group not receiving the chiropractic manipulation because we would be denying them the benefits. You get what I'm saying? The ethics argument has been pulled out of, I don't know where it got pulled out of, but it's anti-science. It's not based on the scientific method. So this elite group of what I call non-scientists, they have essentially violated science. They have one yardstick for themselves and another yardstick for other systems of medicine. You could even argue this has some imperialism flavor into it, some neocolonialism flavor into it, but it doesn't make any sense to me. Right? So the ethical argument is something that you need to be aware of, because what this really brings back to is that we need to go back to science, and that's where we started. Because ultimately, if you're not practicing the scientific method, you start moving into a form of a caste model. Believe me, because I have some direct connection to some superior being that only I know, so you should follow me. Okay? And I would argue that's why this vaccine issue is such a powerful issue. And I would argue it's even more powerful because it's occurring in Massachusetts. It's occurring in Boston, which is supposedly the mecca of medicine. I mean, how many medical schools are here? The opportunity to discuss openly this issue, and I'm not saying pro-vax or anti-vax, but just bring this back into, are we following the scientific method? There's a bill in Congress right now, a guy called Chuck Schumer has put in. It's quite extraordinary. It's almost reminiscent of the Council of Trent. It's Bill, I think, 729, which says there will be no more discussion about climate change. No government agency can discuss it because there's scientific consensus. Okay? Which means this is what the Council of Trent did. They said there will be no one can discuss anything that goes against the Bible because there's consensus that the Bible is true. The edicts of the Council of Trent were used against Galileo. It doesn't matter if 99% of the world, people think in this room that the sun goes around the earth. Right? Because one guy could actually have evidence to the contrary. That's a scientific method. That's truth. So what we're moving to is a violation of freedom, because you're not allowing discourse. In major universities, coming back to this, major universities have become essentially the oldest profession. I'm not saying there are not some good people there, but because of the tenure process, because of the funding process, you have to stay in line. And by the way, Massachusetts is a center of two of the most important universities in the world, MIT and Harvard. I think 42 degrees north, 72 degrees west is the longitude and latitude. And I argue if there is a place that we have an opportunity to focus on, it's that location. Because this is where Boston is called Athens of the world. What goes on here goes everywhere throughout the world. And it is not just unfortunate what occurred with Jeffrey Epstein. Jeffrey Epstein was funding Harvard and MIT. The president of MIT, after he even knew he was a convicted pedophile, still signed and took more money. And he's running his own internal investigation. I've asked for Raphael Wright's resignation, okay? They had one guy resign. What you're looking at is, think about the important message here. Jeffrey Epstein took advantage of children, and people look the other way. And you as mothers are starting to bring up a very important customer service issue about your children. And people aren't listening.
How do we get to this?
Well, first of all, we need to arm ourselves with a different way of going at them. So what I wanted, it's a great question to summarize this. So A is you're not doing science, number one. B, you're not doing engineering. And 3, MDs and pediatricians are not experts in this. They have been given an eminence that they don't deserve. I repeat, they are really tech support people here. Because most of the medical education has become a recipe model. I hate, there's some great MDs, a lot of friends of mine, but it's a model that you go in and you're following a set of protocols. And most of those protocols are being sold to you by a pharmaceutical company. So the MD, I repeat, is the end of a very complex systems process. So we need to educate ourselves and move this discussion. Hey, that's great. I'm sure you care about your patients, but you're not qualified to answer the questions on risk. You don't know what risk is. You don't even know biological engineering. You don't know where all of these vaccines came from. Can you show me a risk assessment model? And that's the discourse that we need to move to. That's why when Candace started sharing with me, I just looked at this and I said, there needs to be a scientific discourse. So we invited an open invitation on October 26th. I think about 450 people have signed up, close to, I think, 20, 30 MD scientists. And people, and we're saying, let's have an open conversation on doing risk assessment. And what we're going to do is make it all public. Anyone can observe. And the two things that we're going to do in that conference are, A, let's look at every literature that's published, organize it into these different categories. We're building a taxonomy. That's one of the purposes of the conference. The second is, we're going to take a set of case studies in engineering, how a nuclear power plant gets built, how a airplane gets built. And there are particular methods. And we're going to say, this is a gold standard. Where is that standard in vaccine development? And we're going to point out there are gaps. So I think the critical thing here is we need to move the discourse into recognizing that the engineering risk assessment process likely does not exist from what I've seen. B, the people, the end delivery people here are not qualified to answer the risk question. And C, at a much more fundamental question, I talked about the innate and the adaptive immune system. Do we in fact know the risk of getting a vaccine versus not getting the vaccine? Finishing up with the measles example, after vaccines were given, remember I said, if you looked at the history of measles, 1963, the measles vaccine was decided to be created. Why? Going back to the bridge analogy, and hopefully this will tie it all up. Remember I gave you the 1 out of 100, the 2 out of 100 example? Well, measles, when you got it, I mean, I got measles. There's a lot of people in this room, if you're probably 50, 60 or older, you had measles parties. It was a rash and, it went away and people actually got inoculated through this process. The reason the measles vaccine was created was people started finding out there was neural inflammation, SSPE. This is the term for sclerosing, subacute encephalitis. And based on And people found out that a certain number of people are getting this neuroinflammation, brain inflammation, and that number was originally, by the CDC stats, if you can hold them to that, around 1 out of 100,000. So 1 out of 100,000 people were not getting vaccinated, or who got measles were getting neuroinflammation, which is 0.001%. Follow me? So someone decided, I didn't decide, I don't know if anyone in this room decided, but someone decided that 0.001% was too high. So they did reinforcement, like the bridge, which is we have to give people vaccines. So thereafter, the level of neuroinflammation in the public right now is around, some people, I hate to use this word because it's such a broad word, autism, right? But let's think about it as neuroinflammation because that's what shows up in autism and a particular protein. It's 1 out of 88. So that is 1.136%. So now neuroinflammation after the era of vaccines is 1.136%. The neuroinflammation at the time of the measles, what they were detecting was 1 out of 100,000. 0.001% versus 1.136%. That's a factor of, 1,000 difference. So it's like the bridge example, right? That we've actually, now, is there a correlation? We don't know. But if you saw that and you got a call on your customer service line, hey, I'm seeing more issues with my Apple after I did that app upgrade, right? My screen is blinking, right? Something's wrong. You wouldn't say, screw off, you're an idiot, right? You don't know what you're talking about. You would, because Apple would probably be liable. In this case, the liability has been removed. Apple would better do it because Samsung will come in and eat their lunch, right? From a competitive standpoint. So fundamentally, what you have here is the question of risk has never been put forward to the community. And you have the third aspect that the fourth aspect, all of these things are being intertwined, the interactions between these vaccines. I'm sorry.
I don't know that risk is a relevant argument because the whole risk assessment model reveals intention. If you build an airplane that's meant to fly, the intention is to make it fly, the risk assessment works. Because if it doesn't fly, you have a,